Before we dive in, don't forget to like, share and subscribe. And make sure to hit that notification bell so you never miss a video. If you're a history enthusiast, you already know that the Second World War wasn't just fought with guns and tanks. Entire families, soldiers and partisans battled another enemy just as relentless, the cold. Cities bombed to rubble, homes stripped bare of chimneys and fuel, forests emptied of firewood. The challenge of staying warm often outweighed the threat of bullets. What I want to share with you today isn't found in glossy history books. These are the practical heating methods civilians and soldiers devised when everything modern failed. Techniques that transformed scraps, rubble and scavenged metal into life-saving warmth. By the end of this guide, you'll see how ingenuity, necessity and raw survival instinct produced some of the most efficient and clever heaters of the era. Systems still valuable to off-grid enthusiasts today. Trench stoves returned to civilian life as practical indoor heaters. Long before they became relics of the First World War, trench stoves found a second life during the Second World War. Families in occupied cities and bombed-out villages rebuilt these simple metal and brick devices to heat rooms and cook meals simultaneously. The principle was straightforward. A narrow horizontal chamber concentrated the fire's heat, while a small chimney carried smoke safely outside. These stoves stretched the life of minimal fuel, allowing a single handful of coal or small logs to heat a room for hours. If you wanted to replicate this today using a steel ammo box or welded sheet, metal works well. Line the interior with firebrick to focus heat and improve combustion. The wartime versions were often crude, but they illustrate a key survival principle: controlled heat with safe smoke. Extraction can maximize both efficiency and safety. Families rebuilt stone and clay mass heaters to conserve scarce fuel. Fuel shortages forced rural communities to revive centuries-old techniques. Large masonry or clay heaters, long abandoned in favour of coal and gas, were reconstructed from broken brick, rubble stone and clay dug from gardens or riverbanks. These massive structures absorbed heat slowly, radiating warmth long after the fire had died. Wartime adaptations were simpler, sometimes rough-hewn, but the principle endured. Even today, a small brick firebox surrounded by a thick outer layer of stone or cob can create slow, steady heat in a cabin or off-grid setting. These heaters were indispensable in long winters, keeping homes stable and conserving every precious piece of fuel. Rocket-style stoves delivered rapid heat from tiny twigs and sticks. Long before the modern survival movement rediscovered rocket stoves, Eastern European families had already mastered their basic design. These were typically L-shaped tubes of clay or metal, allowing air to rush through the horizontal feed tube while the vertical chimney carried heat into living spaces. They were highly efficient, consuming minimal fuel while producing maximum warmth. To recreate one, a simple L-shaped firebrick or stovepipe construction, insulated with clay or ash, is enough. The wartime versions were crude, yet they demonstrate a critical lesson. Clever airflow management can turn the smallest sticks into hours of dependable heat. Wherever abandoned garages or army depots left scraps of fuel, civilians converted metal cans into slow-burning oil heaters. A small trickle of kerosene, used engine oil, or even animal fat dripped onto a superheated metal plate, producing a controlled flame. The result was surprisingly high heat output with minimal fuel use. Wartime families, they really depended on controlled delivery rather than the type of fuel itself to safely produce warmth. These days, if you want to recreate that system, you'd need a sturdy metal plate, a small adjustable valve, and a stable base. The lesson here is quite clear. Control is truly the key to both efficiency and safety. In bombed-out towns and, areas with workshops, sawdust was actually abundant and highly valued. Families would fill metal cylinders with tightly packed sawdust around a central rod, then remove the rod to create a chimney for slow combustion. Just one burn could last 8 to 10 hours, making it absolutely ideal for small apartments or basement shelters. When pressed tightly, the sawdust burned gradually from top to bottom, providing steady heat where firewood simply wasn't available. This system really shows how, quite often, innovation springs from necessity, turning what would otherwise be waste into a life-saving resource. Partisans and civilians in occupied territories frequently relied on underground shelters to avoid detection. Earth-insulated fire pits delivered heat through buried channels, keeping flames out of living spaces and dispersing smoke safely outside. The length and angle of the channel were critical. By the time the smoke exited, it was faint and cool, making it nearly invisible. This principle, separating fire from living space, was a hallmark of wartime ingenuity. Modern survival shelters can replicate this technique using a fire pit set a safe distance away from the living quarters and a channel buried in compacted soil or clay. In cities destroyed by bombing, residents salvaged old plumbing to create makeshift hot water radiators. Fires heated metal tanks, and gravity-driven circulation pushed warm water through pipes to adjacent rooms. These systems were neither elegant nor perfectly safe, but they multiplied the heat from a single fire across multiple spaces. For today's off-grid homesteads, the concept still works. Position a water tank near a wood stove, run pipes upward and outward, and, natural convection distributes heat without pumps or electricity. Families revived one of the oldest forms of radiant heat. Dense stones, heated in an outdoor fire and placed indoors inside metal boxes or wrapped in cloth. The stones radiated warmth slowly, providing steady night-long heat without open flames. This was especially valuable for households with children or elders, where safety and conservation were paramount. Selecting dense, dry stones was critical, as they stored heat effectively without cracking. These 8 systems are more than history. They are lessons in survival engineering. They show how ordinary people, faced with extraordinary circumstances, applied ingenuity to meet basic human needs. Their methods still hold relevance today, whether for off-grid living, historical reenactment, or understanding how resourcefulness can overcome scarcity. If you found value in this guide, make sure to subscribe to Warfront Survival, leave a comment with your thoughts or experiences, and share this video with someone who appreciates real wartime ingenuity. These methods deserve to be remembered and applied.